Except for Mercury and Venus, every planet in our solar system has at least one moon.
Some of them have a lot of moons. Jupiter and Saturn have well over 50 moons orbiting each of them. Even Pluto, some other dwarf planets, and asteroids have moons.
Beyond our solar system, thousands of exoplanets have been discovered, and it's likely many of them have moons too, all with unique sizes, textures, and patterns.
Some of the images you just saw are a few of the amazingly diverse moons throughout our solar system.
And some of them were frying pans.
Follow along as you learn about astronomy you can do at home, and learn which of those images were moons and which ones were frying pans.
This is STEM in 30.
Hi, I'm Marty.
And I'm Beth, and we both live near a very large city, Washington, D.C.
Where do you live? In a city? In the country? Or somewhere in between?
No matter where you are, astronomy is for you. There are many ways that you can look at and learn from the sky, including virtual ways.
To understand what we can see when we look up, we need to figure out what our perspective is first. Let's see how our home in space, Earth, is situated.
Our perspective has everything to do with how Earth moves.
Hey everybody, I'm Julian Zeus McClurkin of the World Famous Harlem Globetrotters. Let's imagine for a second that this basketball is Earth. It spins on its axis, an imaginary line running down the middle. This is called rotate. Earth rotates on its axis like this. And this is Darnell, Speedy, Artis with our moon. The man on the moon. The moon spins on its axis. It's rotating just like the Earth. The moon spins a lot slower than the Earth, but we're gonna do it faster because it's just way more fun that way. Not only is the moon rotating, it also orbits or revolves around the Earth. That means it goes around the Earth. Fell off the axis. Time to get a little more complex. Look over here at the sun. The Earth revolves around the sun. All the while, it's still rotating and the moon is rotating on its axis and orbiting around the Earth at the same time. That means the whole cosmic neighborhood is moving. All of this moving, rotating, and orbiting, that affects what we can see in the night sky.
So remember, spinning on the axis is rotating.
Moving around an object, that's called revolving. See?
And this is out of this world.
Ha!
Marty, you were a teacher for a long time. How did you teach moon phases in your classroom?
I used the Karate Kid before it was Cobra Kai cool. Wax on, wane off.
Now we know that every teacher on the planet has used these to teach moon phases. And while delicious,
here's a way that you can create a 3D model to help wrap your head around this concept.
That you can try at home.
Hi, I'm Sarah, and I'm going to show you how to build a moon phase board so you can see how moon phases are created by the movement of the Earth and the moon. Here are the things you will need for your moon phase board. Ping pong balls. You'll need at least 8, but it's good to have extra. A larger styrofoam ball about the size of a baseball. Some black foam board, a black Sharpie, yellow paint, a tape measure, newspaper, paintbrush, and a pencil. You'll also need a hot glue gun and a box cutter knife, so make sure you have an adult to help you with those parts. The first thing you'll want to do is carefully paint your styrofoam ball yellow. This will represent the sun. Next, you'll want to color 1/2 of all your ping pong balls using the black Sharpie. This will represent the side of the moon that is in shadow. The other side will be the side that always faces the sun. Once you're done making your moons, plug in your hot glue gun and get that warmed up. Now get your foam board and box cutter. First, take the tape measure and find the middle of your foam board. You can do this by measuring the width and the length of the board. Find the middle of each side and mark it with a pencil. Then measure from across the board and find the middle of all 4 sides. Mark that with a pencil and punch a small hole through the board. If you want to have a nice round circle to stick your head through, cut a piece of string about 12 inches long. Tie a pencil to one end of the string and pull the other end through the hole in the middle of your board. Next, draw a circle around the hole. Now cut the big hole for your head using the circle you just drew. Your knife will need to go all the way through the foam board. Be very careful about what is underneath while you're cutting. Now that your board is ready and your sun and moon phases are dry, it's time to get gluing. First, glue down your sun at the top of the foam board like this. Then glue down one of your moons next to your hole. Remember that the white side of your moon represents the lighted side and should always be facing toward the sun. On the far side of your board, across from your sun and the first moon, glue your next moon. In between these 2 moons, on the right and left-hand sides of the board, place your next moons. Now that you have these 4 glued, place 1 moon in between each of them. Before you glue your moons down, double check to make sure the white side of your moon is always facing the sun. Once you've glued your moons down, stick your head through the hole and rotate the board around counterclockwise, which is the direction of the moon's revolution around the Earth, and see the phases of the moon. Starting with the new moon, followed by the waxing crescent, then the first quarter, waxing gibbous, and full moon. Next is the waning gibbous, followed by the last quarter, and finally the waning crescent before returning to the new moon. This model shows the basic moon phases, but don't forget that the phases don't skip from one to another. It is a slow, month-long progression to go from the new moon, where you can't even see it, to the full moon, and back again to the new moon. Be sure to check out the moon tonight and let us know what phase it is down in the comments.
The moon looks like it changes shape because of its orbit around the Earth.
But sometimes how we see the moon can change entirely, like during an eclipse.
And those are a big deal.
Back in 2017, there was a solar eclipse that was visible for the entire United States, and parts of the country were able to see totality.
Eclipse mania swept the nation. I was at the museum in downtown DC where we could see a partial eclipse, and it was crazy.
I got a chance to head back to my hometown, which was in the path of totality, and after battling a thunderstorm, we had an amazing view. Dark skies in the middle of the day, the diamond ring, we saw it all.
Don't forget lunar eclipses. They can be pretty stunning.
Here's your guide to eclipses.
An eclipse is a brief but amazing event in the sky when the sun or moon gets blocked or darkened. A solar eclipse happens when the sun is blocked by the moon. During the eclipse, you can see the sun gradually disappear as the moon passes in front of it. If you are located in the right part of the Earth, you will see the moon block the entire sun and the whole sky darken for a few minutes. The time when the sun is totally covered is called total solar eclipse. Let's look at this from another perspective, out in space. We can see the sun shining onto the moon and the Earth. As the moon passes by the Earth, it blocks a little bit of sunlight and casts a shadow onto our planet. Anyone located inside that shadow would see the moon perfectly lined up with the sun, totally blocking the sun's light. People outside that shadow would see the moon only partially covering the sun. What causes a lunar eclipse? A lunar eclipse happens when the moon is darkened by the shadow of the Earth. We are used to seeing the moon go through phases, which are caused by the changing angle of the sun and not the shadow of the Earth. But during an eclipse, we see the moon slowly disappear as the Earth blocks sunlight from reaching it. If the moon passes completely inside the Earth's shadow, it goes totally dark with only a faint red glow. This is a total lunar eclipse, sometimes called a blood moon. To see what's causing the red glow, let's take a look from the moon's perspective. The Earth is blocking any direct sunlight from reaching the moon, but a small amount of light shines through the Earth's atmosphere, where the blue colors are absorbed, and only the red light makes it through. This filtered red light from the atmosphere shines onto the moon, giving it the soft red color. We don't see solar and lunar eclipses every month. As the moon goes around the Earth, its orbit is slightly tilted with respect to the sun. That means that most of the time, when the moon passes in front or behind the Earth, it's a little too high or low to be perfectly aligned with the sun. A couple times per year, its orbit will put it at just the right angle to line up with the sun and create an eclipse. By carefully measuring the orbits of the moon and Earth, we can predict when the alignment will be just right for an eclipse to happen.
Marty, what are some of your favorite things to look at in the sky?
I love looking at the moon, the sun safely, and stars.
Don't forget the Milky Way and satellites.
The International Space Station is amazing to see passing over.
And during certain times of year, you can see meteor showers.
And don't forget about planets. The Greeks called them wandering stars because they moved differently than other stars.
Here's how to find those wandering stars.
When we look into a clear night sky, we see many points of light. A few of those bright dots are planets, which are visible without a telescope. How can you tell what's a star and what's a planet? Here are 3 simple rules to guide your planet hunting. First rule, look for something bright. Look for a dot that is brighter than most stars you can see. Planets appear brighter because they are so much closer to Earth than stars are. Second rule, look for something with a steady light that is not twinkling. Stars twinkle because the air above our heads is wiggling the light as it comes to our eyes. If we took away the atmosphere, nothing in our sky would twinkle. Planets are closer than stars and look bigger to us, so even when the atmosphere wiggles a planet's light, we don't see it twinkle like stars do. Third rule, look for something that's in the same path that the sun and moon travel across the sky. Each day the sun rises in the east and sets in the west. Notice where you see the sun and moon over the course of a day. Then look for planets in that same part of the sky. Now you know how to find planets. When you find something that is bright, not twinkling, and along the same path as the sun and moon, you've probably found a planet. Because the planets orbit around our sun, they will slowly change location in the sky. Each planet will be visible for a few months before disappearing into the sun's brightness. Using these planet hunting rules throughout the year, you can look for the different planets that appear in your sky.
Today's astronomers are incredibly diverse, but that wasn't always the case. Here's a story about Vera Rubin.
Vera Rubin loved astronomy since she was a child. From her bedroom window, she would watch the stars move, and she dreamt of becoming an astronomer. She went to Vassar College, which was then an all-women's school, and in 1948, she graduated as the only astronomy major. She wanted to go to Princeton University for graduate school, but Princeton did not permit women to even apply. She did finally get a PhD from Georgetown University, but her research was largely dismissed by the field dominated by men. After pressing for a job at the Carnegie Institution, Rubin decided to study a topic that wasn't of great interest to the majority of astronomers. She really wanted to carve her own space in the community. So Rubin studied the motion of galaxies. Using a new type of instrument, she observed how stars orbited the center of a galaxy, and she found that stars near the edge didn't orbit the way that astronomers predicted they should. They were moving much faster. This led Rubin to an idea that astronomers had theorized but never observed, that there must be some missing mass we call dark matter that is in the galaxies and is speeding up the stars. A new telescope is being built in Chile, which is now called the Vera C. Rubin Observatory. One of the many things astronomers will use this telescope for is to better understand the nature of dark matter. This is a lovely tribute to a woman who, before passing away in 2016, served as an advocate for young women in astronomy everywhere.
Today, astronomy is open to everyone. Anyone can go outside and look up. This includes Hakeem Olushe, who studies the transfer of mass and energy through the sun's atmosphere.
Lou Strolger, who studies supernovas and works with the Hubble Space Telescope.
We also have two amazing astronomy educators that work with us at the National Air and Space Museum, Becca Lundgren and Shauna Edson.
Marty, do you have a favorite constellation?
I do, I like a lot of them, but my least favorite is Orion. It's a giant waste of space.
That joke is horrible. I give it 3 stars.
Hey Beth, did you know I entered a star naming contest?
How'd you do?
I didn't win, but I won a constellation prize. Do you know anything about constellations?
Not much.
You should at least learn about Ursa Minor. It's the bare minimum.
Do you know what a light year is?
It's the same as a regular year, only less calories.
All bad jokes aside, looking at constellations is pretty cool.
Here's what to look for.
On a clear night, we can see countless stars in the sky. How do we make sense of all those tiny points of light? Humans throughout time have made sense of the sky by creating imagined shapes among the stars. We call these patterns constellations. Scientists around the world use 88 specific constellations that have been agreed upon. Most of those are based on Western mythology, but every culture around the world has created its own understanding of the sky through different constellations. You can decide for yourself what shapes you see in the stars. To learn the commonly used constellations, you don't need to memorize them all. Start by learning one, then use it to help you find others that are nearby. Astronomers call this star hopping. Let's practice star hopping with the constellation Orion, the Hunter. It is visible in the evening sky between December and April. Orion has several bright stars, including 3 that make a line known as the Belt. You can use Orion's belt to find 2 other nearby constellations. Trace a line from Orion's belt toward the east until you reach a very bright star. That is Sirius, the brightest star in our sky and part of the constellation Canis Major, the dog. Trace a line from Orion's belt toward the west until you reach a bright red star. That is Aldebaran, the Eye of the Bull constellation Taurus. The constellations you can see will depend on where you are on Earth and the time of year. The amount of light shining in your sky, known as light pollution, can affect how many stars you see. In a well-lit place like a city, you'll see just the brightest stars in the constellation. In a place with a darker sky, you'll see more of the fainter stars. No matter where you are or what day it is, use your star hopping skills to start learning the constellations one by one.
If you haven't noticed during this episode, we've had some stellar backgrounds.
We don't always have to go outside to explore the sky. We can use tools, like the open source software called Stellarium, to explore what the sky looks like across time and space.
The constellations we just explored have Western names and stories, but there are so many other star patterns and stories from peoples around the world.
When we look up at the night sky, we can see so many things: the stars, planets, the sun, the moon, and we can make meaning from what we see. One of the ways that we can make meaning from the stars today is because of a man named Mau Piailug, who shared the knowledge passed down from his ancestors about star lines that you could use to navigate. This was shared with the Polynesian Voyaging Society and how peoples from Hawaii and many other places in Polynesia can navigate using the sky. Let's take a look at the sky. What do you notice? Do you see any bright stars? The first bright stars that I see are a curve of stars to the southwest, kind of like a C or a hook. This is actually part of the star lines that Mau Piailug shared. This is the chief's fishhook, or the fishhook of the demigod Maui. It refers to the demigod Maui's fishhook that he used to pull the islands out of the sea. The fishhook will always be to the south and is part of a star line that points to the north. If we follow the fishhook north, we can find another bright patch of stars, the Navigator's Triangle, made out of these 3 very bright stars that we can see all summer long. These 2 constellations make up the star line that also mark the Milky Way and travel across the sky in the summer. Let's see if we can notice any other bright stars, to spot any other star lines in the sky. I noticed these 4 bright stars here. These make up a star line called Calliope ao Coelho, or the Kite of Coelho. This is going to be very prominent in the fall, and it's referencing the story of the kite lost as a child by the chief Coelho. Each one of these 4 stars that make up the kite's body are one of his ancestors. We can travel from the south at the bottom of the kite all the way to the north to Chief Frigate Bird, which is just at the tip top of the Kite of Coelho. These make up 2 star lines that we can see in the night sky during the summer and fall months, and were shared by Maupielug and passed down through his ancestors. People have made meaning out of the stars throughout time, and they still do today. How do you make meaning from the stars?
There are many great star stories from around the world.
Here's one of our favorites from the Smithsonian's National Museum of the American Indian.
Did you ever wonder how the stars became scattered all over the sky? Long, long ago, Ojishanda, the ruler of Starland, was in charge of placing the stars in the sky. Every night he'd walk around the sky, carefully positioning them one by one. One evening, before it was time to go to work, Ojishanda felt very tired. He plopped down his sack of stars, closed his eyes, and nodded off. While Ojishanda was sleeping, his pet red fox, a cunning little creature, decided to have some fun. So he grabbed the bag and took off with it. The stars spilled out everywhere, all over the sky. When Ojishanda woke up, he couldn't believe what had happened. With so many stars strewn all over the sky, there was no way he could ever gather them together again. The stars would have to remain scattered across the heavens. Now it takes poor Ojishanda all night long to walk around Starland, lighting the stars one by one. Sometimes when the snow is deep or Ojishanda is tired, he can't get to them all. That's why you can't always see a lot of stars in the sky, especially in the winter.
Did you know scientists are looking for planets outside our solar system? And they've found a bunch.
These are exoplanets, and when you go out and look at constellations, some of those stars may have planets around them.
Some of them are just wild. Scientists believe that there are planets where it may rain rubies and sapphires.
Then there are the super puffs, which have the density of cotton candy, but not as tasty.
Let's take a look at how you can put your imagination to work.
Art is for everyone, and the only limit is your own imagination. This especially goes for exoplanet art. We can't see these faraway planets in great detail, so we have to use our imagination when considering what they might look like. The authors of the book Exoplanets explain that there are a lot of exoplanets, and there is no wrong way to imagine what they may be like.
The astronomy community is discovering planets outside of our solar system at the rate of about 1 per day. And if you use that rate and see how many planets are around our nearby stars, we suspect that there are more planets in the observable universe than the combined number of heartbeats of all the people that have ever lived on Earth.
We figure that if you can imagine any exoplanet, provided it doesn't violate some law of physics, it probably exists somewhere.
You can create your own exoplanet art using some simple materials. Start with a poster board and just a few colors of spray paint. First, put down the colors of your primary planet, usually 2 or 3 colors, and think about shadows and where the light is coming from. After layering your spray paint, take a plastic bag and lay it over and pull it up. This creates the planet look. Now cover your planet and paint your sky black. Next, flick white paint over the painting to represent stars. Use a straight edge to spray straight lines. Uncover your planet and voila! An exoplanet! You can always learn additional techniques like comets, foregrounds, and rings.
Exoplanets are not the only inspiration for space art. The Juno mission to Jupiter has inspired some amazing pieces. Scott Bolton, the principal investigator, discusses how science influences art and how art influences science.
And I really believe there's an intersection of art and science which is very important to us all in almost all fields. And here you see a lot of the images, and this is one of them, where somebody posts something that they're inspired in some artistic fashion. There's science in this too. They're taking the swirls and they're showing you in a new way, and that is exactly how science works too. Is I look at a picture from a different way and I all of a sudden see some feature that I wouldn't have otherwise recognized. That's the idea of the original stretch of colors. Mm-hmm. This is more extreme. I'm not sure scientists would do what a lot of the amateurs are doing, but they are going to start now because we're learning so much from it. But it's also just a beautiful picture.
No matter what your medium or your inspiration, you too can be an exoplanet artist.
Paint, pencils, Photoshop, or even pancake batter can be the way that you share your imagination with the world.
What far out places will you dream up? What art will you make?
We've talked a lot about going out and observing the sky.
But we don't want this to be a theoretical discussion. We want you to go outside.
Like tonight, if it's clear.
There are a few simple things that you can do to make your observing a success.
Like, wearing warm gloves and packing delicious hot chocolate.
Here are some simple tips you can follow.
Looking at the sky is really pretty easy. Start by finding a place to look up. Anywhere is fine as long as you're not under a direct light, like a street lamp. You don't have to leave the city or even your doorstep. Next, figure out what direction you're facing. There are a lot of ways to do this. You can use a compass or a compass app on your phone. Then, find out what's in the sky and where by using a sky map. You can find them in books, on skymaps.com, and there are several free sky map apps. Grab a seat, a blanket, and a friend. Give yourself a few minutes outside and let your eyes adjust. For a better view, use binoculars or a telescope. You'll be amazed by what you discover right above you.
The sun is setting on this episode, but we wanted to go back and revisit something we mentioned earlier.
We showed you some pictures of moons from around our solar system, and we showed you some pictures of frying pans.
If you're keeping score at home, let's see how you did.
These were all real moons found somewhere in our solar system.
These are not the moons you're looking for. These images are all frying pans found throughout the kitchens of our team.
We hope you get outside to enjoy the sky. And let us know what you see in the comments section.
And if you like this video, be sure to follow STEM in 30 on Facebook and Twitter, and subscribe to the National Air and Space Museum's YouTube channel.
Thanks for watching.
And clear skies. You look surprised when we get one right.
Today's astronomer. Marty, you were a teacher for a long time. How did you teach moon phases in your classroom?
Well, this didn't work well. Sorry.
Cookie? Cookie? Cookie?